So this topic is related to the image formed by a converging lens or a convex lens. As we have discussed already about the convex lens, we define certain parameters for a convex lens. A lens which is having a refracting surface, it allows the light to pass through it. So for a convex lens, there are two types of lenses. One is convex, the lens which is thinner near the edges and thicker at the center, that is convex. And the concave is a lens which is thinner at the center and thicker near the edges, that is known as concave. So convex lens is known as a converging lens because when the light rays passes through this convex lens, it focuses them, it converts them at one point. That's why we call that as a converging lens. Whereas concave lens is known as a diverging lens because it spread out the wave which are the light rays which are passing through it. That's why we call that as a diverging lens. So in this topic, we will discuss how the image can be formed by a convex lens. So for this image formed by a convex lens, first example, if this is a convex lens, so imaginary line, in reality it's not there, it's just in imagination. So imaginary line which is passing through the center of the lens, that is known as the principal axis. So this line is known as the principal axis. The point where this line touch the lens, that is known as optical center. And the distance between the optical center and the point where all the light rays converge, that point is known as the focus. And the distance between the optical center and the focus, that distance is known as focal length. So the focus is denoted by F. There is another point which we call 2F, and this is always done with measurement. In exam, when you draw this image formation, you should always measure the distance from center of the lens to the focus, and they normally mention the focus, that focus might be 5 centimeter, 3 centimeter, 2 centimeter according to the question. Same way on the left hand side we'll have F and 2F. So three ways the light can pass through this convex lens. Number one, if it is parallel to the principal axis, it will pass through the focus. So parallel light ray to the principal axis will pass through focus. The second one, it can be a ray of a light passing through the center of the lens, so it will pass straight. And the third one, if the ray of the light is passing through the focus, it will go parallel. So these are the three ways the light can pass through. We have already discussed this part. There's a quick revision. That's why I just repeat this. In the last session, we have already discussed, but for a better understanding, I will just repeat this topic, how the image is formed. So example, if you want to show how image is formed, if the object is beyond 2F, like if the object is after 2F, so this F and 2F, this is always done with a measurement. So in exam they mention the focus, so according you will measure the focus F and then the double of the focus, that will be refers to 2F. Now object is beyond 2F, object is after 2F, like example object is anywhere after 2F. So first what we do, the parallel light ray, so from where it will pass, if light ray is parallel, it will always pass through focus. And we'll all take another light ray from the tip of the object, that will pass straight. So the second light ray will pass straight. So the two light rays, when they pass, one the parallel passes through focus, one through the center will pass straight, and as a result these two light rays will combine or join at one point, and the point where the two light rays combine or join, what we call this, that is the position where the image is formed. So characteristic of this image, when we compare the object with the image, what we find, the comparison, object is bigger and the image is smaller. So we can say that image is, it is real. Why we call that as a real? Because it is formed by actual intersection of the light rays after refraction. That's why it is real. And it is diminished or small in size, and it is inverted, or we can say upside down. And this type of image is formed in the camera, like whenever, if you have a camera, this is how the image is actually formed in the camera. The object is big or large, when the light rays passes through the convex lens, they will converge at one point. So when they converge on the screen of a camera or the backside, there is a film in the camera. This is not a digital camera, it's a normal camera which develop an image. So object in practical, the object is much larger, but what image is formed? Image is formed is smaller, or a diminished image is formed. Is it clear, this part? The first one, how the image is formed when the object is after 2f or beyond 2f, or objects which are far away from the lens. Then the second one, if object is at 2f, object is exactly at the position of the 2f, or the twice of the focus. So first, the parallel light ray, from where it will pass through focus. One through the center of the lens, it will pass straight. So when these two light rays combine, they will join at again at 2f. So when object is at 2f, the image will also form at 2f. So in this case, the size of the object and the size of image will be same. So when we move the object closer to the lens, as you can see, the image size will increase. But if object is between f and 2f, so first the parallel light ray will pass through focus, and one through the center will pass straight. So as a result, when these two light rays will join after passing through the lens, this is the position of the lens. So the point where they will intersect, that is the image. And when you can see here, compare the object with the image. This is a real image. Why it's a real image? It is formed by intersection of the two light rays. And it is inverted. What is the meaning of inverted image? Inverted means it is upside down. Like if object is like letter A, the image will be upside down A. And it will be larger in size. So when object is between f and 2f, the image size will increase. So this is a real and an enlarged image or magnified image, and where we use this, it is used in projector or photographic enlargers. So this is a projector lens. As you can see, this is a projector lens, and the slide, that is small in size. But when the light rays passes through, first the parallel light ray will pass through the focus, one through the center will pass straight. So if the object was like this, if this was an object, as a result, it will produce an enlarged image on the screen. That's how the projector works. It increases the size of the image which we see on the screen. But that is also a real image. Why we call it a real image? Because actually, when the light rays refracted, they intersect by themselves. So if the light rays intersect by themselves, the image form is refers to a real image. So this is also a real image. Real images can be seen or can be taken on screen. Then when the object is between the focus and the lens, so first the parallel light ray will pass through focus, one through the center will pass straight. So these two light rays will never meet, these two light rays will never intersect, because the distance between them is continue to increase. So what happened when we look from other side of the Like here's an object lens and we look the object from through the lens. So our brain sense light is coming straight from the object. So when our brain try to produce or try to recreate this, so as a result it produces it backward, and this is a position where we will see the image. But this image is virtual image. Virtual means it's imagination. It's in reality it's not there. It's just our imagination which create an image. It is enlarged and it is upright. And this type of image is formed in a magnifying glass. By example, to read a very small text, we can use this magnifying glass. So as a result, what happened? This is again imagination is there, that the text or the object is so small, when the light rays passes through, it enter our eye and our brain sense light is coming straight from the object. So as a result, the object will appear, the image of this object will appear much larger. So we are able to read this text. So, and this image cannot be seen on screen. Like example, if I place a screen here, if I place a screen, I cannot see anything on the screen. Why I cannot see anything on the screen? Because this is imagination. Like the person at position A is imagining that the image is formed, but in reality it's not there. So even a person is there at B, he won't be able to see anything. Why? Like on the screen, he won't be able to see, because this is just an imagination or imaginary image. An imaginary image cannot be taken on seen on screen. Is it clear the concept of a convex lens using as a magnifying glass? Now we have some questions related to the lens, as we have discussed some of them in the last session. Mainly we discussed the structure one. It's the MCQs we have already discussed, so this session we'll discuss the structure question. Related to the lens. Okay, in this question, as you can see on the figure, 7.1 shows a converging lens and its principal axis. The points label F are each principal focus of the lens. So they only mark principal focus, or they did not mark 2F. On the figure, draw two rays from top of the object to locate the image and label that as I. So what you will do in exam, you will first draw a parallel light ray. So the parallel light ray, from where it will pass through the focus. Then through the center of the lens, you will draw another light ray. It will pass straight. The position, the point where the two light rays will intersect, that is the position where the image will form. So when we represent the formation of the image, the point where the two light rays actually intersect, that is the position where the image will form. So we write that as I. Is it clear that how the image is formed by this convex lens? So first the parallel light ray, even you can consider, there's also another way, you can consider one through the focus. If it is passing through the focus till the lens, but you have to take always from the tip of the object. So if it is passing through the focus till the lens, it will pass straight. And one through the tip of the object, that will pass straight through the lens. So as a result, when the two light rays will intersect, that is the position of the image. So you can draw in this manner, or you can take the third, only two you need, but you can draw the third one the parallel one to the principal axis, it will pass through the focus and it will converge at a point. So all the rays will converge at or combine at one point. As a result, it will produce a real image. Then underline three terms to describe the nature of image produced by magnifying glass. So when we use a magnifying glass, so what are the characteristics of the image? It is not diminished, that is wrong. It is enlarged, that's correct. It is not inverted. It is not real. It is not same size. It is upright. Upright means if head of the object is up, head of the image will also be up. And it is virtual. Virtual means it cannot be seen or it cannot be taken on the screen. Another question related to the lens. The figure 7.1 is a diagram of a converging lens used to produce image of an object. Each point mark F is a principal focus. So they already marked focus. Write down three terms to describe the image produced. So look, here is an object, image produces upside down. So an upside down, whenever image produces upside down, it means always it is a real image. So it is inverted first. That is one thing. It is real. Real images are always inverted in a convex lens, and it is when you compare the size of image with the object, the images appear to be larger. So image is larger than object. So we don't have to draw. We don't have to draw here. We just have to mention, like, compare the object with the image. So whenever we compare the object with image, if object and image are on the opposite side of the lens, it means it will always be a real and inverted. And the size, larger or smaller, depends on the size of object. If object is closer to the lens, image will be larger in size. If object is away from the lens, image will be smaller in size. Now the next one is figure 7.2 shows a plane mirror. An object O and observer I is there. On the figure, draw two rays from the object and reflect it to the observer I. So we have to draw the two rays from the object which strike the surface mirror and bounce back to the eye. Then on a figure 7.2, complete your diagram to determine the position. How we can determine the position of the image? Because a plane mirror also, it's a virtual image, it is imagination. So it is just an imagination. So what our brain sense that light is coming straight from the object. So when it produces them backward, the two light rays. So the point where the two light rays intersect, by imagination, it should be straight line. I'm using a dotted line here, but you can use a ruler. You should use a ruler and just join them. So the point where the two light rays will intersect, that will be the position of image. And keep one thing in mind, the object distance and image distance should always be same. Like if this, because in a plane mirror, the object size and image size or object distance and image distance is same. So if this is 2 centimeter, the best way to draw, like example, to make it simple drawing, if this is object is 2 centimeter from the mirror, you will draw an image also at a distance of 2 centimeter. And then join the points between the eye and the image and then draw the arrows. So basically what happened, and rub this distance so that you will get a most accurate answer. So what happened, the two light rays which are coming out from the object strike the mirror and enter the eye. And when we locate them, this is the position where the image is formed. And this is a virtual image. Why it is a virtual image? Because in reality, the two light rays does not meet. So it's just our imagination which create this image. That's why we call that as a virtual or imaginary image. Is it clear? Any doubt till this point? Another question related to the lens. Figure 7.1 shows a converging lens and its principal axis, the point f1 and f2 are each the principal focus of the lens. On the figure, draw two rays from top of object and locate the image. So how to locate an image? First, the parallel light ray till the center of the lens. From where it will pass through focus. Draw the line as long as possible, that's not an issue. Then one through the center, it will pass straight. So it means these two light rays will never meet. So if these two light rays will never meet, what is missing here? The eye, there should be an eye here. So when our brain senses the light is coming straight from the object, so it will produce these two light rays backward. And when it will produce this light rays backward, it will create an image, and that is virtual or imaginary image. So here's an object, this one is image. So, and it is easy to remember, whenever object is between the focus, the image is always virtual. If it is after the focus anywhere, after F, either on the left hand side or on the right hand side, if it is after F, then it will be a real image. But if it is within the focus, then it will be a virtual. The object is moved to the left so that it's further away from the lens. On figure 7.2, draw a diagram for new arrangement. So now in the second one, the first one we already did. Now in figure 7.2, the object is moved away. So how to draw? First, again, the parallel light ray. If the light ray is parallel, from where it will pass through? It will pass through the focus. One through the center of the lens will pass straight. And even you can take a light ray passing through the focus will go parallel. So these are the three light rays which can pass through a convex lens. Then underline three terms describe the image. So what are the three terms which describe the image? It is diminished. No, it is not diminished. How to? We have to compare the size here. First thing, it is real image because it is formed by actual, and it is inverted. Then about the size, what you have to do? You have to place a ruler, the scale, and you have to measure the distance. Or you can either measure the distance between the lens and the object, or you can measure the height of object and height of image. So when we compare, because the comparison, so when we compare it, the image appear a bit larger than the object, so that's why we write enlarge. If it was smaller, then we write diminish, and if it is too big, then it will be magnified. Enlarge or magnified you can use in the same context. Another question related to the lens. Figure 7.1 shows a convex lens being used to produce an image. The object, two light rays passes through, one passes through the focus, one through the center, and when we produce them backward, it produces an image. Place a tick in the table. Describe the image. Number one, this image is magnified or enlarged. It is not inverted. It is not real. It is not same in size. It is upright. Upright means if object head is up, image will also be up. And it is virtual. It cannot be taken on screen because this is just imagination. So whenever object is close to the lens within the focus, the image form is always a virtual image which cannot be seen or taken on the screen. On figure 7.1, mark with the letter E indicate the position of the eye. So where the eye is there, we should place eye here, E. We don't have to draw an eye, we just have to write with the letter E, but I'm just drawing to explain the idea. And then what is the application? We use it as a magnifying glass. Now this question, I want everyone to solve this with me so that you will have a better understanding, because this is related to the measurement as well as the drawing. So in a space below, I want everyone to draw. So you should have a pencil, and you will use a pencil to draw this image. In a space below, draw a ray diagram to locate the image of an object height 1 centimeter, which is placed 5 centimeter from a convex lens of focal length 2 centimeter. Draw your diagram full size. You are advised to locate the lens roughly in the center of the space. So what we do, first we'll draw a principal axis. Always draw the principal axis. First draw a horizontal line which is known as a principal axis. So after drawing the horizontal line, mark the center of this line. Like if you draw say 8 centimeter, then 4 centimeter will be the center. And that is the position of the lens. So position of the lens you can represent by a dotted line. So use dotted line to show the position of the lens. Do this part. Then in the question they mention the focal length is 2 centimeter. So using your scale or a ruler, measure 2 centimeter and mark F. So F should be at 2 centimeter. On the right hand side 2 centimeter, on the left hand side also 2 centimeter. And then mark 2F 4 centimeter. So mark the focus F, which is 2 centimeter. Using a ruler or the scale, measure this distance. This will be 2 centimeter. And measure 4 centimeter and mark 2F. So both sides, on the left hand side as well as on the right hand side. Then after marking F and 2F, they mention the object height is 1 centimeter, like the height of object is 1 centimeter, but it is placed, how much? It is placed 5 centimeter from the lens. And they did not mention left or right. So if they did not mention, so you can place the object left side or right side. So if 2F is 4 centimeter, it means you will measure 5 centimeter from the lens. Measure this distance 5 centimeter from the lens. And the height of the object is 1 centimeter. So the height which you use for this object should be 1 centimeter long. And the object is placed 5 centimeter from the lens. You can place on the left hand side, you can place on the right hand side. It won't make difference. Then the parallel light ray, how to complete? Now from the tip of the object, draw the parallel light ray. Horizontal, it will pass through focus. And one through the center of the lens will pass straight. So the point where the two light rays, because the one which is through the center of the lens will pass straight or go straight. So the point where the two light rays appear to intersect, that is the position where the image will form. And where the image form, label that as eye. So here is an object and this one is a image. So complete the figure. This is done with the measurement. So complete this to show how the image is formed. Then the next question is also related to formation of the image. The last question. So state the full description of the image. So this image, it is virtual and magnified and upright. So virtual images are always are magnified for a convex lens and they are upright. Use the letter on the figure 7. Identify the focal length. How to identify the focal length? Because look, when the parallel light ray is there, when the light ray is going parallel, it will pass through the focus. So basically point S is a focus. So what is the focal length? Use the letter on the figure. So what is the focal length here? So S is actually representing the focus. S is a point which S is a focus, and focal length is actually a distance between R and S. So if S is a focus, the distance between R and S is a focal length. On figure, draw an eye. So suitable position of the eye. So eye will be here. At this point, we will have an eye to observe this image. Then figure 7.2 shows an object on the left hand side of a converging lens. The principal focus of a lens is marked F. On the figure, draw two rays to locate the image of this object. So what you will do, you will measure this distance and same distance you will make other side, that will be F. Now how we can locate the image? So first, the parallel light ray. From tip of the object, the parallel light ray will pass through the focus, and one through the center of the lens will pass straight. So the point, the position where the two light rays will intersect, that is the position where the image will form. So this will be the image formed by the convex lens. Then on figure 7.2, draw one another ray. So we have to draw the third ray. So how we can draw the third ray? We can pass through the focus. So if we pass through focus, where it will go? It will go parallel. But all the rays, these light rays will intersect or they will meet at one point. Is it clear how the image is formed by a convex lens as a magnifying glass? In this case, it's not a magnifying, but the convex lens can form an image as a magnifying glass or it can form a real image. In this case, the image is real, inverted, and it is a bit smaller in size. So this was the last question related to topic. lens.